Alright, hello and welcome. This is going to be our classwork help video for the geometric sequences worksheet. Question number 1 asks us to determine if the sequence is geometric, and if it is, find the common ratio, the eighth term, and the explicit formula. So what we're looking for is there a number that we are multiplying by each time to advance in the sequence? And we can find out what number we're multiplying by going backwards and doing the division. So do 213 divided by 21. So 213 divided by 21 gets me 10.14, meaning that to move forward, I must be multiplying by 10.14. Well, let's see if that holds true. What's 2133 divided by 213? 10.01. So this is not geometric, so we can move on. Just write not geometric. Doesn't mean it's not following a pattern, doesn't mean that it's not a sequence, it's just not a geometric one. All right, let's look at number 2. What am I multiplying negative 2 by to get all the way up to positive 12? Well, I must be multiplying by a negative 6. Let's see if that holds true. If I multiply by negative 6 again, do I get to here? Yes. If I multiply by negative 6 again, do I get here? Yes. So yes, it is geometric. The common ratio equals negative 6. And for the eighth term, we want to use the formula that a sub n equals a sub 1 times r to the n minus 1. So if I want to find the eighth term, I'll take the first term and multiply it by our common ratio, negative 6, raised to the power of 8 minus 1 for the eighth term. Plug this whole thing into your calculator, but I'm going to do negative 2 parentheses negative 6 to the power of 7. Just do that step in your head. And then I get that the a sub 8 equals 559,872. All right, we'll just do one more here about, oh, this is pretty similar. We'll do number 4. I'm multiplying by negative 4 each time, so yes, this is geometric. So the common ratio equals negative 4. A sub 8 equals negative 4 times negative 4 to the power of 8 minus 1. So negative 4 times, in parentheses, negative 4 to the 7th equals a sub 8 equals 65,536. All right, find the term named in the problem. Okay, so these are definitely geometric sequences. We can double check that, but I can see here the common ratio is times 2 each time. If I couldn't figure that out, I could do the division trick. Now I need to find a sub 12. So a sub 12 equals our first term times 2 raised to the 12 minus 1 power. So negative 3 times 2 to the power of 11 equals negative 6,144. And we should be checking our answers as we go. Negative 6,144. Okay, let's just skip on down. Given two terms in a geometric sequence, find the common ratio and the term named in the problem. So here we've got a sub 4 and a sub 5. So because these are right next to each other, we can use that division trick. Just do a sub 5 over a sub 4 to figure out what the common ratio is. Always do the next term divided by the previous term. And we get, this is, I think, negative 3. It is negative 3. So that's our r value. Now we got to find the 11th number. Well, here's what we're going to do. We're going to treat this, we're just going to back up the whole sequence by 5. Or, well, by 4. So we'll treat this as our first term, 243 as our first term. We're going to multiply it by negative 3. Well, you can just count this out. So I'm going to count with my fingers. To get to the 6th, 7th, 8th, 9th, 10th, 11th, I need to do 6 steps. So I backed this up by 4, so I backed this up by 4, but that gets me to 7, but you subtract another one because it's only 6 steps. All right, now I do 243 times, in parentheses, negative 3 to the power of 6, and I get 177,147. All right, let's look at 10. To go from a sub 1 to a sub 6, we go from 3 to negative 3,072. So how many steps did we make there? We went from a sub 1 to 2, 3, 4, 5, 6. And it looks like we made 1, 2, 3, 4, 5 steps to get from a sub 1 to a sub 6. So you can just take the difference there, 6 minus 1, to get the number of steps. So 6 times, or 3 times some ratio to the 5th power equals negative 3,072. We can divide both sides by that 3. R to the 5th equals, let's see, negative 3,072 divided by 3 equals negative 1,024. We could raise both sides to the 1/5 power. That's like taking a 5th root. So I'm going to go to the power of, in parentheses, 1 over 5, and I get r equals negative 4. Now I do have the first term, so I can just plug this right into the formula. 3 times negative 4 to the power of 9 minus 1. 3 times, in parentheses, negative 4 to the power of 8 is 196,608. 196,608. Okay, I think you can get the last two on your own. We'll start with a very similar problem in our next lecture video, and have a good rest of your day.